Today we're talking about another way to solve a quadratic equation. This does not involve factoring, and this only really works in certain circumstances or certain occasions. And we're going to think about this for a second in terms of inverse operations. So if you recall that the opposite of addition, right, is subtraction. And so anytime we're trying to undo addition, we can subtract. The opposite of multiplication is division. Anytime we're trying to undo something that's multiplied, we can divide. And the opposite of something being squared is the square root. So when you're solving by taking the square root, this is actually probably one of the easier methods, but it only happens when you don't have a b term. Because if you have a b term, like if you had something like this, you're going to be taking the square root. Well, this is a perfect square, so when you take a square root of an x squared, that simplifies to x. When you take the square root of x, that still leaves you with the square root of x. So you can't do this when you have that middle term there. So we want to make sure that we have no b term when we're doing this. Our b term is 0. And the first thing that we want to do here is we want to isolate the x squared, not x, the x squared. So we're going to start by isolating x squared first, meaning if there's an a value, we get rid of that. Then once we're done doing that, we take the square root of both sides. Oops, I wrote the same thing. Take the square root. Once we have that isolated, we should take the square root. And what happens here is I have this remember plus or minus. So I want to show you guys something real quick. When you take the square root of an x, that's going to give you a plus or minus answer. So let's just look, for instance, at this. So if I asked you what the square root of 9 was, you would hopefully tell me that that's 3, right? But if I make this into an equation like this, x squared equals 9, and I take the square root of both sides. Well, an equation is saying what values for x would make this true. So when I get this and I just write x equals 3, but what about this? So I can square 3, right, and get 9, but can I also square negative 3 and get 9? Because remember, negative 3 times negative 3 is positive 9. So when you take the square root after you're done, you have to make sure that you put a plus or minus there for an equation. The square root of 9 is not negative 3. But when you have an equation, x squared equals 9, that gives you a solution of 3 and negative 3. Those are the two numbers that you can plug into this equation to where it is a true statement, just like we saw right over here. And then the last thing we want to do is we want to simplify the square root. Okay, so let's look at a few examples like that. So here I have this first example, and I'm going to start by isolating the x squared. So this is the only type of method where you don't set it equal to 0. If it's already set equal to 0, then great. This is where you're actually trying to get x squared by itself. This is the only quadratic method where you do that, where you don't have it set equal to 0. A lot of times students will take the square root right here, but the x squared term isn't isolated, so we have to get that by itself. And then we get x squared equals 9. And we just actually did this one, right? So now that I had this by itself, I can take the square root of both sides. That undoes the x squared and gives me x equals plus or minus the square root of 9. Well, what's the square root of 9? It's 3. And that's my answer. Here I'm gonna isolate the x squared. I'm gonna subtract 25 from both sides, and I get negative x squared equals negative 25. And then I'm going to not take the square root. What am I doing? I need to get rid of that negative sign, and that gives me x squared equals positive 25. Once we're here, we can take the square root of both sides because x squared is by itself. That gives us x equals plus or minus, what's the square root of 25? It's 5. So these are ways that you can solve as well. When you're solving by the square root, your answers will look like this, plus or minus some number. So what happens if you take the square root of a number that doesn't simplify nicely? So I'll show you what I mean by that. So we're going to, in a sense, prime factorize the number underneath the square root sign, the radical. And then we're going to circle and pull them out in pairs, circle pairs and pull them out of the square root. So I want to show you a little bit of what that looks like in practice, because none of these, like, you don't know what that is, but we're going to talk about how to simplify square roots. The same thing as when you learn how to simplify something like this. You would say, oh, well, 2 can be divided by both the numerator and the denominator, so we can divide both sides by, or both the top and the bottom by the same thing, which is 2, and that would simplify to 1/2 type of thing. So you can do the same thing with square roots, and you need to. So this is how we do that. I'm going to prime factorize the number 8. So I'm going to write this as 2 times 4, and then I'm going to break this down as 2 times 2. And from here, since I'm talking about a square root, that means that I'm going to take out pairs. If it was a cube root, then I would take out 3s. I would circle groups of 3. But since it's talking about a square root, I'm going to group pairs like that. And so when you group pairs, if you group 2 2s, you're going to pull one of them outside. And then whatever is left that is not circled, that is part of your prime factorization, that stays inside. Okay, if you had more than, we'll see what that looks like. So this would simplify as 2 square roots of 2. I can break this down as 2 times 12, and then that can be broken down as 3 times 4, and 4 can be broken down as 2 times 2. And so the only pairs I have are 2 times 2. So I'm going to pull one of those 2's out. And what's left over is 3 and a 2. But those are multiplied because those are factors. So I'm going to multiply those together to get 6. Notice I'm not putting a plus or minus because I'm not solving anything to get an equation. Okay, 32 can break down as 8 times 4. 8 can break down as 4 times 2. 4 can break down as 2 times 2. This can break down as 2 times 2. And so I group pairs. That, and what's left over is 2. So I'm going to pull out 2 2's, and they're multiplying together. So I'm going to multiply 2 times 2 to get 4. And what's left over inside is the square root of 2. 72. First thing that comes to mind is 8 times 9. 9 can be broken down as 3 times 3. That's 2 times 4, and that's 2 times 2. We're looking for pairs, so I have a pair here and a pair here, and what's left over is that 2 that's not circled. So I'm going to pull a 2 and a 3 out and multiply them together to get 6 square roots. 6 square roots of 2. So we're going to need to simplify this, simplify our square roots anytime it doesn't simplify like before, like a perfect square. So we're going to see some examples like that right here. So same idea, we're going to still isolate the x squared term, and we're going to get x squared equals 12. Well, I think that was one of the examples we just got done simplifying. If I take the square root of both sides, we get x equals plus or minus, and over here to the side, I'm going to simplify this. So I'm going to have this 2 times 6, and 6 is 2 times 3. I have pairs right here. No, I didn't simplify this. So I have pairs. I pull out one of those, and what's left over is that 3 that stays inside. So I have 2 square roots of 3. Over here, the x squared is already by itself, so I'm going to take the square root of both sides. And that undoes the x squared, and I get x equals plus or minus. And then I'm going to simplify do a prime factorization of this. 3 times 9. 9 is 3 times 3. Pull out pairs. What's left over is the 3 inside, so I'm going to pull out one of the 3 of the pairs and then keep that there, and that would simplify as 3 squares of 3. Okay, and finally, we got this last one. We're going to start off by dividing 2 by both sides. And we'll get x squared equals 24. And then I'm going to take the square root of both sides. And I get x equals plus or minus. I'm going to simplify this by the square root of this by saying 6 times 4, that's 2 times 2, that's 2 times 3. I want to group pairs. I got a pair of 2 there, so that's going to come out. And then what's left over is this 2 and this 3, which I got to multiply together to get 6. Ooh, I didn't mean to put plus. Oh, yeah, these are equations. Yeah, I do want to put plus or minus. Sorry. This is where I'm putting plus or minus because these are equations. Okay, I'm not going to go into a whole lot of detail, but I wanted you guys to use your calculator to type these in. So these top ones are perfect squares, and what you see is if you type that in, you would get that, you would get that, you would get that, and you would get this. And down here, you might think you might change this to like that, a -1 or a -2 or something like that. But what we have to remember is that when you have a square root of something, that's basically saying that you can write something, or that's saying that you can write something where you square it, where you square that number, and you get this. Well, if this is a -1, there's no way that I can square something to get a negative number, because that's a negative times a negative. So what you'll see is that if you type these into your calculator, every single one of these right here is undefined, meaning it will come up with an error. Those actually are called imaginary numbers. And we're going to use the letter I to denote them. So an imaginary number, let's see if I have this on the next slide. So the square root of a negative number is considered imaginary, but they're part of our solutions. We have real and what's called complex solutions, and which we'll talk about later. Complex solutions occur when you have an imaginary number. So when we simplify a negative square root, we use the letter I to denote that. And what we do with that is, that's for an imaginary number, is we write I on the outside of the square root. So we'd have something like this. We'd pull that negative sign out, and we would write it outside of the radical for the square root. So we're going to solve the following quadratic equations by taking the square root, and we'll see that we have negative signs in there and figure out how to do this. So real quick, this first example looks kind of like a difference of squares, only it doesn't have a minus sign. So this can't factor. So this wouldn't be x plus 5 times x minus 5. This actually has no real solutions, but it is going to have imaginary solutions, and we can see that by this. So when we get this, the x squared by itself, we get that, and then we take the square root of both sides. And the first thing I want to do is, if I see a negative sign under that radical, I'm going to put, first of all, I'm going to remember to put plus or minus, and then right next to the right of that, I'm going to put my letter I, and I'm going to make this a positive square root of 25. And now I'm going to look inside of here and simplify that. Well, we just talked about what that was. That's just a square root of 25, which is 5, and I'm going to write that as 5i. So I know that the square root is behind the I, but the proper notation, the coefficient goes in front of the I. So this would be I5, which is the same thing as 5i. So this would be our answer right here. This example, we would add 24 to both sides. And then we would divide by -3. We get x squared equals -8. Once again, we're going to have an imaginary solution. And we get x equals plus or minus. Since I have a negative sign, I'm going to bring that outside and denote that with the letter I. And then I have the square root of 8. So once you get here, this is not a perfect square. We're going to have to simplify the square root of 8 by doing a prime factorization. That's 2 times 4, and that's 2 times 2. Pull out pairs. So this would become x equals plus or minus. Since I have a pair 2, I'm going to have 2i. That's coming from these square roots of 2, what's left over in the prime factors. And then lastly, subtract 28, we get 4 squared equals -28. We're going to divide both sides by 4, and we get x squared equals -7. Take the square root of both sides, and we get x equals plus or minus, bring this outside, I square root of 7. And now we're going to simplify the square root of 7. Well, the good news is that 7 can't simplify. So we're going to leave that inside the radical because there's nothing that we can do to pull out a pair. If we try to break this down into prime factorization, 7 is already prime, so there's no pair. So we leave that inside. There's nothing to pull out. That is our answer. Okay, so here I have an example of Mr. Price is playing Modern Warfare, and he is on the top of a building with no more ammunition. So I ran out of ammunition. I have overkill on, so I have 2 guns, but I do have 1 grenade, and I see a bad guy running below, Marksman 0612. I just made this up, so if somebody has that name, I'm not like stalking anybody. I just made that name up out of the blue. This bad guy doesn't see him, so I'm standing on top, and it's important that when I throw this grenade, it's accurate, that my throw is accurate, and that the time it takes for the grenade to detonate is also accurate. So here's a bit of information that may be useful, but once a pin on a grenade is pulled, it takes about 4 seconds to explode. So if I throw the grenade, I want to figure out how long it takes for it to hit the ground so I can see if I'm going to hit this guy. And it's also important to know that a grenade has a blast radius of about 20 feet. So if a guy is standing right here, and this has a blast radius of 20 feet, and my grenade lands right here, it doesn't actually hit him, it should still affect him. So let me see if I can draw. Well, I don't need to draw a picture. I will. I'm standing up here on the top of this building. Here's me. And here's this guy running. He's running away from me. He doesn't see me. And here comes a grenade. And I'm going to try to throw it like this. Well, the path of the grenade can be modeled by this equation where h is the height of the grenade and t is the time in seconds for which the grenade travels. So I'm asked, what am I asked? I said if the grenade has a blast radius of 20 feet, that's really not, that has nothing to do with our equation, but that's just telling us how far we are. And I threw the grenade accurately. Did I cause the marksman to explode? And explain. So what we have to think about here is that I need to try to figure out what my solutions are. I need to try to figure out the time here. It doesn't explicitly say that, but I'm trying to figure out after I throw it and where it lands. Hopefully it probably won't hit him. It'll probably land on the ground. But what would be the time that it hits the ground? And is that time, if that time is somewhere, how much more time do I have before it explodes? And is he in that certain radius that I need him to be? So the way I'm going to think about this is I'm going to set this equal to 0 because I want to find out when the grenade hits the ground, how long it takes for the grenade to hit the ground, so I can see if he is in that blast radius. And so we have to think about, I'll show you here in a second. Let's go ahead and do this real quick. I'm going to factor out a -16 because that's my GCF and I want to keep a positive. So that would give me x squared minus, that's not 8, sorry, that's 4. So that's going to give me this factorized. And then once I get here, I have a quadratic still, so I'm going to keep this -16 in the front, and that's a difference of squares. That's t plus 4 times t minus 4. I'm sorry, t plus 2 times t minus 2, sorry. And so I'm going to set these equal to 0, just the factors that have t's in them. And if I set this equal to 0, t plus 2 equals 0, and t minus 2 equals 0. Here I have t equals 2 seconds. And here I have t equals -2 seconds. We're going to ignore this one because time is not considered negative. So this is going to be what our solution is. So that basically means that when I pull the grenade, I'm going to throw this grenade. It's going to hit the ground. It's going to hit the ground at 2 seconds. But it has about 4 more seconds for, 2 more seconds before it detonates. So if I threw this accurately in a close proximity to where he's standing, it's not likely that he's going to be able to run that fast in 2 seconds to escape the blast. So it's not really like, we don't have a whole lot of information to be able to answer this, but basically I just want to make sure that when you have something like this and I ask you to solve for time, given that we are just taking the square root, actually I should have taken the square root here because that's how we're solving these. Let me do this one more time. instead of factoring. So, I mean, we're going to get the same thing, but I want to get t by itself. Get negative 64, negative 16t squared, divide by negative 16, divide by negative 16. That gives us positive 4 equals t squared. I take the square root of both sides, and I get t equals plus or minus the square root of 4, which the square root of 4 is just 2. So t equals plus or minus 2 seconds. We ignore the negative and say t equals 2 seconds. So I really should have probably specified like how long does it take to hit the ground instead of trying to be creative here. But anyways, that's how we would approach a problem like that, looking at when a grenade hits the ground, finding the time for that. So that is solving by the square root. Good luck.